Hello, everybody. Welcome back to a brand new episode of the Lil Dudes Insect Academy podcast. Wait, before we get started, I just wanted to say thank you for tuning into this episode of the Lil Dudes Insect Academy podcast and just ask you to please hit the like button below or click the subscribe button if you're watching on YouTube or follow this podcast if you are listening. That really helps the show out. But also, if you want to help us further, then join our Patreon. We have an awesome community that is growing there. Or if you want to make a one-time donation, we are a nonprofit foundation, so head to our website. Both the Patreon and the website will be linked down below. But without further ado, back to the episode. I'm your host, Bradon, and I'm super excited to talk with Dr. Amie Norton. So Amie's going to be talking with us about her recent experience with entomology and her career so far and how she's gotten there, and some really cool stuff she's working on with nanotechnology, her background in chemistry. So welcome to the show, Amie. Say hello to the people. Thank you so much for joining me for this.
Thanks, Braden. Thanks for having me on. So I work at Kansas State University. We started our entomology undergraduate degree 2 or 3 years ago, and so we're really excited about it. I work as a research assistant professor right now. I started there as a postdoc, and I actually didn't start in entomology. I started as a chemist. My PhD's in chemistry and my undergraduate's in chemistry. And then when I graduated, I got a postdoc at Bowling Green State University, working on bio-inspired materials. We were making biodegradable materials, and we worked with photoreactions. So we sped everything up with light, and we made hydrogels, and that's material that absorbs water. And then I got a job at the USDA in Kansas. And a funny story is my dad was in the military, and he was stationed in Fort Riley here, so I actually went to high school where I'm in the same town I'm working now.
Wow.
I didn't see that coming, but it's a nice town. So I worked at the USDA ARS, which is the research service, for 3 years, and then I worked in the entomology. Now I work in the entomology department at Kansas State University.
That's really cool. I'm interested to hear how did you end up in entomology after having a background in chemistry? I'm pretty interested in that journey.
Yeah, so the because I didn't have an agriculture background, but I knew how to run the instrument at the USDA. So I really got hired knowing like the chemistry background of how to run like HPLCs and UV visits and that kind of stuff. And then while I was at the USDA, I made a pesticide that could kill mosquito larvae at 1 ppm. And so if you're thinking about, well, what is a ppm? It's parts per million. And so that's like putting a drop of water in a 40-gallon fish tank, I think. And so I made a silver nanoparticle on a micro carrier of ZN. And so the nano is the size, and then the micro is also a size. So a micro is bigger than a nano, and it's all on a size scale. And so we were excited because it killed all the mosquito larvae after 40 hours. And then when we went down to zero point 0.1 ppm, we stopped them from becoming adults. And so that opened the door for me to start a postdoc at Entomology department.
Okay, yeah. So I want to talk about that mosquito pesticide for a second. Um, what's it being used? Like, did someone buy it from you, or like, where is that now? And like, what was that journey like? And that was in your postdoc or one of your postdocs, right?
Right. So we're still working on the patent journey, which is that's a long journey. So first you like disclose the technology, then the USDA has an internal group that says like this has been done before, this hasn't been done before, so then it gets voted on. Then it goes to the lawyers. Then you have another conversation, and then basically they decide if they want to file or not. Then they file
Mm.
it. Then it goes to a patent reviewer, and then they can like accept or reject it. But then you have a chance to respond. So the first time through, they rejected it, and then we responded. So now we're waiting for their review. And basically, they rejected it because they said it was similar to another technology. But then we responded and said, actually, it's different in this way. So it's not
Mm.
uncommon to have to respond back and forth.
I see.
Uh, so there's two different. You can do patenting or licensing. And licensing is like if you have a company involved, they'll license the material.
Mm-hmm.
And so we don't have a company right now that's buying it because we've shown it on a small scale on the bench. We haven't shown it on the bigger scale.
I see.
So I I think I disclosed like 5 years ago, and we're still filing the patent.
Mm.
So
Yeah.
it's
So long process.
yeah, nothing's a fast process.
Mm-hmm.
So
Interesting. Yeah. So, how long did it take you? So you kind of finished it up 5 years ago. How long did it take you to actually like develop this?
yeah, it took about a year because we had to test it more than once to make sure it wasn't a fluke. So we tested it about 3 times, and you also test different batches to make sure something wasn't wrong with that one batch of nanomaterials, and that's why it worked. And then we also test different grains. So we test sorghum, which some people know as Milo, wheat, and DN protein, which is corn protein. And so we published the one on corn protein. The other ones work as well.
Mm. So, what would be like the implication of that pesticide going out? Like, what's the benefit of like the mosquito control that this would cause?
Uh, so one thing people are always worried about is resistance, and so it would be a new pesticide they can use. The other thing is the carrier is biodegradable, so it's more environmentally friendly. And then
Mm.
also the amount of silver you're putting on is not that much. And if you, it's in a water systems, so the amount of silver you're putting on is less than what they put in drinking water, so it's all safe.
Mm. That's pretty cool. Yeah, okay, so mosquito stuff, with the pesticides. So what's some of the stuff you're working on now, with research and at the department and teach? I think are you teaching or?
Yeah, yes, I taught last semester. I taught nanotechnology in entomology,
Cool.
and so each student had their own independent project they worked on. It was the first time
Wow.
we offered the class, so I think they really enjoyed their own research project they worked on. One person worked on Indian mill moths, which is a store product pest. One person worked on biting midges, and we saw how changing the reducing agent of the silver nanoparticles would change the mortality level to biting midges. And then the third person worked on Haitian fly. And so the biting midge project was because when you make silver nanoparticles, you take a silver nitrate solution and you have to reduce it to from silver plus to silver zero. And so to do that, you need a reducing agent. But by changing the reducing agent, you change the properties. And so we were looking at the effects of doing that. So we got some really cool results. And biting midge is a interesting insect because it's also a vector insect,
Mm.
like the mosquito. And then the Indian mill moth, that one's interesting because you see it in grain bin that kind of stuff. And so we
Yeah.
looked at eggshells and we looked at eggshells alone and silver with the eggshells, and we looked at different life stages, so that affects the eggs, small larva, large larva, and then what they call wanderers, so it's looking to spin its cocoon. And so we saw mortality at all the different stages.
Mm. So, were these students able to like choose whatever they want to work on, or were these like kind of ideas that you already had that you were kind of offered as options?
One was working at the USDA on biting midges, so I picked a project that was on a pest she was already interested in.
Mm-hmm.
The other one had worked on ham mites, so he had worked on store pests before, so I gave him a different one to work on because it was similar to his interest. And the third one was getting a master's on the Haitian fly, so I changed the nanomaterial that he was working on because it was similar to the pest he was working on, or it was the same pest he was getting his master's on. So I
Mm.
tried to pick something that they were already interested in.
That's pretty cool. Yeah, really, really interesting. And so, what you mentioned, that you're working on some new things with eggshell, um, pesticide. Tell us a little bit about that. Like, why is that? What's exciting about that? And tell us a little bit about that.
So the exciting part is that there's no pesticide on the eggshells, and it's a food waste. So you're recycling food waste. It's biodegradable, and it works similar, we think, to diatomaceous earth.
Mm-hmm.
And but the problem with diatomaceous earth is that if you put it in wheat, it changes the bulk density, which
Okay.
means that when people go to sell their wheat, it's by the bushel. Well, if you change the bulk density, you get less for it, is my understanding. So
Mm-hmm.
you want something that's not going to change the bulk density, and that's something we have to look into. So if we can replace it with eggshell, um, we can perhaps do something that won't change their um, the amount they're getting back from. And if you're farming or you're going into, if you're a farmer, what you care about, one thing you care about is your yield and how much you're getting for that crop.
Yeah.
So going to turn it back in and then changing how much you're getting is it's not a good deal for you. The other thing is we can make an organic product if we are using organic eggs, and that's an easy fix.
Mm.
And we have a paper submitted. We're just waiting for the reviews.
Mm-hmm.
For the red flower beetle, we used eggshells and it killed 100% of the adults in 7 days. But when we went to the larva, for some reason, it didn't kill all the larvae. But if we put spinosad, which is organic grade, it did kill all the larvae.
Mm.
And spinosad alone, for the red flower beetles, I can't remember the percent, but it was less than 50% after 14 days. And so now we're at 100%. And so it going to the nano eggshell powder helped improve that rate.
Mm.
And one reason, sorry,
So
is
no, go ahead.
is because nano has high surface area, but you're also making it smaller, and so you're increasing the bioavailability of the chemical if you're using a chemical, and so you're increasing the absorption amount.
Mm. So, what pests would this be effective towards? Like, what did you test it on? And is it like a general pesticide, like a broad spectrum pesticide, or are you testing it like to be used for a specific application?
Uh, so right now we're looking at different pests to see what it would work on. Um, so we know the red flower beetle because that's where we started, but we want to start looking at different store pests and different types of store pests to see how it works, if it works across the spectrum. Because if it does, that would be really nice, and it would be
Hmm.
really cheap.
Yeah.
I I think that I saw a statistic. You know, we make like millions of tons of eggshell waste, and so it would give us a use for eggshell waste.
So, so I'm a little unfamiliar with how it's like how it works and like how it's made. So is it literally like like powderized eggshell? Like how is it applied and like what does it actually do to the insects?
Yeah, it's literally powderized eggshell, and we applied it to the bottom of a vial, and uh, so eggshell, it has a calcium carbonate in it,
Hmm.
which is a desiccant, and so we're not sure the mode of action, but we think one mode of action could be that it's working as a desiccant.
Hmm. So it's, clogging the various pores that the insect breathes through, or it's, you know, sticking to certain parts of the insect that allows it to breathe, and it's drying up. Is that right?
Uh, yeah, I think so. I've taken some
Mm.
SEM images of them, and they're which SEM is scanning electron microscopy, and so you can see they're like covered in this powder,
Mm.
and so I think it's just drying them, and their mouthpieces in their head doesn't look the same as the control.
Mm.
That's the best I can describe it as, but we haven't really gone down the road of describing the mode of action.
Interesting. Yeah, that's pretty cool. And yeah, it would be really inexpensive, organic, potentially, um, not harmful to humans, right? So like for crop um, pesticides, it could be really good.
Yeah, and even for like used in food, that kind of stuff, it should be okay. Um,
That's cool. Um, yeah, so I'm curious how your schooling was. Like, so you have a background in chemistry. How did that happen? Where did you go for all of those degrees and like what kind of got you into that?
yeah, I took a chemistry class in high school, and I just really loved chemistry. I guess I was kind of like one of the weird kids who really enjoyed
Mm-hmm.
it.
Mm-hmm.
So I decided in high school I wanted to be a chemistry major, and then I never changed my major.
That's awesome.
I always tell my undergraduates that it's normal to not know what you want to do. So if you're a high school student and you're like, I don't know what I want to do, that's perfectly normal.
Yeah.
Or if you're an early college student and you don't know what you want to do, that's perfectly normal.
Oh yeah.
And then I went to undergraduate at University of Missouri, and I majored in chemistry, and I got an ACS certified degree, which is American Chemical Society degree.
Okay.
So if you're going to grad school, there's a BA or a BS. So if your school offers the BS, American Chemical Society, if you're going to grad school, you should get that one for chemistry. If some other schools they only offer like the BA, depending on some people go to smaller schools.
Mm-hmm.
So it depends on what your school offers. And then I minored in sociology and religious studies because I thought it was important to be well rounded. And when we're implementing science, it's important to understand different points of view,
Yeah.
and be able to explain things to people and why you want to implement something and why is it important. And I don't work on this side, but when scientists were trying to tell people why it's important to get vaccinated for COVID, one thing that's important is to explain that and understand the point of view of what people are coming from and why they're scared or why
Hmm.
they think that way. Um, because you can't just like go in and be like, well, you should do this because you're not going to get anywhere.
Right.
And then I was able to study abroad twice while I was in undergraduate. So
Oh
I
wow.
studied Shakespeare one summer in England. I took a 2 week business class. One week we were in Czech Republic, Prague, and the other week we were in Vienna, Austria.
Mm.
Because I think it's important to, one, be as diverse as you can if you're able to, and then it's also important to have a global perspective if you can. Um,
Yeah.
and when you see other parts of the world or other things, it just opens up your view of things. So
Absolutely.
I grew up a military kid, so I've lived abroad and stuff, and I just enjoy seeing the world and learning from different things. And then I went to University of Cincinnati, and I went straight into my PhD. Um,
Mm.
in chemistry, a lot we don't stop for our masters, which is different from other disciplines.
Yeah.
So then it took me about 8 years to get my PhD. I got my PhD in inorganic chemistry, but my degree just says chemistry. And so inorganic, we work with a metal and synthesize it with ligands. And then I worked on environmental sensors. So I made a colorimetric sensor to nitrate and VOCs. So what that means is that it would change colors in the presence of nitrate, which is an anion in water, and then also VOC, which are volatile organic compounds, which are like acetone, methanol. So acetone's in your nail polish remover.
Hmm.
And then in chemistry, a lot of times you do have to do a postdoc before you think about doing like a professorship, unless you're going straight into teaching.
Right.
I really enjoy research, and so I knew I wanted to do research, so I did a postdoc.
Okay. Um. Yeah. Really. Really cool. So, what was your postdoc? I mean, one of them you mentioned was the mosquito. Um. Was the mosquito pesticide? But what was the other one?
The other one was Bowling Green, where I worked on the bio-inspired materials, and I worked at the photo center, and so a lot of it was light-driven work, and so I learned a lot about photo reactions and stuff like that.
Hmm. Yeah. Really. Really interesting.
I forgot one thing. While I was in
Yeah.
my PhD, I did a year intern at NIOSH, which is the National Institute of Occupational Safety and Health,
Okay.
and we worked on worker safety. Like if there was a spill in the laboratory, how would you assess it without sending somebody in? And so we
Oh,
made
cool.
a Roomba robot that would go around and like tell you where the spill was. It had a sensor on it. It was pretty neat.
Oh, that is cool. Yeah, and that was, uh, yeah, that's really cool. Um, so was that like a project, and is it like a thing that more people are using, or was it kind of just like an interesting thing you were working on at the time?
It's a project. So people are I think people are using the PIDs in a worker safety program. So it's a PID that you wear, and we did sensor arrays. People are definitely doing sensor arrays for different things. The Roomba robot, I don't know if they're using for that, but I think they are using Roomba robots to detect for other things.
Hmm.
We wanted to use like a human in the lab just to wear our PID, but to do human studies, even if they're just wearing a sensor, it's really hard to get past a human protocol board.
Right.
And so I had to get something done that year I was there, and we didn't get past the board because we got all our paperwork in, but just getting approved is quite
Mm-hmm.
undertaking, and
Mm-hmm.
so we had to come up with a plan B. So we instead of a person, we put it on a Roomba robot.
I see.
So,
Oh,
but
that's cool.
it was neat, and I have a video. I can send you the video if you want to put it up.
Mm-hmm.
So,
Oh, that's cool. Yeah, okay. Um, so I'm interested in, I mean, you sort of mentioned it a minute ago, but I'm interested in how you transferred over from chemistry to bugs. Like, when did you make that leap? Was it like through your mosquito project, or had you always kind of liked bugs or interested in them? What was that process like?
My sister laughs now that I'm working on bugs because
Mm-hmm.
I'm the person that like sprays myself with DEET to death because I like want to avoid bugs. They like me, but
Uh-huh.
the feeling's not neutral.
Mm-hmm.
So I had made these particles, and I thought, well, what's the application I'm going to use them on?
Mm-hmm.
And we had a unit that worked on mosquitoes, and I saw people were testing silver and gold nanoparticles to mosquitoes, and I thought, well, let's test them and see what mine do. And so I just talked to our collaborator and I tested them, and it worked really well.
Mm.
And so it just kind of happened through collaboration.
That's cool. So now you're actually teaching entomology. What was that jump like? Like, did you have to take like a crazy crash course on bugs to be able to teach about them, or did you kind of know about them quite a bit throughout your schooling?
I didn't really know anything about bugs, so I kind of picked up through different projects about them.
Mm-hmm.
So I kind of find that once you get a PhD, when you're put on a different project, you learn a lot about whatever it is to
Yeah.
be able to accomplish the project. And so I'm not teaching like taxonomy or something where you have to know all the parts of the bugs.
Mm-hmm.
And so what I'm teaching is more the nano application of it. And then when it comes to like the insects and that stuff, what I know is what I picked up through my different research projects and what I've looked up on my own and learned that way.
Mm. Yeah. So it's been kind of a long process of gleaning things from different people and projects and.
Yes, I always think that like being a PhD or being a scientist, I mean, in general, is having the ability to learn because you're so
Right.
specialized in one area, and a lot of times what you go into is not that niche area. I mean, sometimes it is,
Mm-hmm.
but sometimes what you're doing is you're showing that you can either take that niche area and apply it to other places, which I take some of the skills I learned, like the instrumentation, the material science, and apply it. But you're also showing that you can learn and pick up skills.
Yeah.
And so that's the most important. And so if I was going to give people advice, the one advice I would give is take all the opportunities you can to learn skills because you don't know when they're
Absolutely.
going to come back. And no one can take that knowledge away from you.
Yeah. Um, yeah, that's really awesome. And I'm kind of curious what your thoughts are on like the future of nanotechnology. Like, what what do you see the implications of some of the stuff you're working on and like other people, the industry as a whole, like with nanotechnology in medicine? Like, where do you see this? Why is this so exciting to you? Like, where do you see it going in the future?
We've seen like nanotechnology and medicine really take off, and it's really made a profound change. And we're starting to see in agriculture nanotechnology starting to show up a lot. So I'm working on entomology, but I also have collaborators in agronomy and and I think we're going to see the changes that it made in medicine happen in agriculture. And so now we have nano carriers in medicine. We can deploy the medicine right where we want it. Some of the advances we have in cancer research are due to nanotechnology. And so I think we're going to see similar things in agriculture where we can target the specific pest. The pesticides that we put in our house are safer. Like there's certain things with nanotechnology that you can have open up at certain pHs. So, like, if your child swallowed it, the nanotechnology would not open up, so it would be safe around children.
Mm-hmm.
That kind of stuff. I think you're going to see more of that. And then I think you're going to see the advantage of the costs that now you have to use less chemical out there. And so it should drive the cost down because if it's more expensive than what we're using, no one's picking it up. And so I like to take waste, like agriculture waste we already have out there, and turn it into a pesticide or a herbicide because it's going to keep the cost down. And then we should be putting less agrochemicals on that nanotechnology. It's what we're hoping for. And so, from a business perspective, if I'm a company, I'm excited about that. The other thing we have to think about with nanotechnology is in the past, some hurdles to get it out there is that if I synthesize in DMF and then you go to a company and you synthesize it, you have all this DMF waste. That
Mm-hmm.
costs you to throw it out or not throw it out, but like dispose of it.
Yeah.
And so, what we try to do in my lab is we synthesize an environmentally friendly solvents, water, or we try to get rid of the solvent at all. We don't synthesize in any solvent. And so now when we go to the company, their waste is almost none. Um, and so thinking about those at the lab bench and not being like, I have this great technology, can you synthesize it on the large scale? Is I think that's what's going to help us break through those barriers.
Yeah. Yeah, really exciting, really cool things to think about. The way that we could possibly tailor specific pesticides to a specific pest, right? I mean, that's really cool. And then obviously in human health, and then like what you were talking about with mosquitoes, like there's tons of research in mosquitoes for stuff like this because it also relates to human health very closely as well. Mosquitoes carry a lot of disease, all that kind of stuff. So really, really cool, exciting things that you're working on. So personally, like what are some of the things that you are interested in looking at and working on in the future?
So in the future, I'm interested in looking at how nanotechnology can really change how we're applying a lot of stuff if we can actually lower the amount of chemical we're using out there. And then I'm also looking at what is the fate of the nanotechnology in the environment. And so one thing that limits us is we can apply the nanotechnology, but then there's no way to track the nanotechnology. And so I'm looking at a way to track the nanotechnology as well. And so one thing you could do is put a fluorescent probe in there, or like when you spray it, try to do some kind of fluorescence, and then that might also tell you if you go out there and you see the dye, your pesticide should be there. So
Right.
it could save you from overspraying as well. The other thing that I'm excited is sensing applications, and so detecting biosecurity things. So this isn't necessarily an entomology thing, but it's an agricultural application. So
Yeah.
out in western Kansas, they have the aquifer, and there's sites that have uranium and nitrate contamination. And
Hmm.
so if you can put a dye in the plant that would change colors, if the water was contaminated, you would know if there's uranium or nitrate contamination there.
Yeah.
But one thing about understanding if nitrate is there, you don't have to put down your fertilizer with nitrogen because you have nitrogen right there. And so it could save you a lot of money on fertilizing because sometimes over fertilizing is a problem. And fertilizers is one problem of nitrate contamination. It's the runoff from the fertilizer. And so
Mm.
if you stop the over fertilization in some places, you can actually decrease the amount of nitrate out there. Um, and so that would be really interesting to do.
Mm. Oh, that's cool. Um, Yeah, kind of piggybacking off of that last question, what are some of the other like exciting things you have um, that you want to do in the future for like maybe trips you want to go on or other research you want to try or maybe some other changes at the program that you'd like to help with, anything like that that you're willing to share.
Yeah. So our program is, we're all kind of innovative. It's a fun program. We have a student coordinator there. It's a lot of fun. And so, if anybody's out there and they're thinking about being an entomology major, I would encourage them to look us up and
Hmm.
come out for a visit and see what they think. Um,
Yeah.
and everyone's like really nice that I've met here. Um, the other thing is, personally, me and my mom, we take these trips. We're going to England and Wales this summer.
Nice.
And then I'm going to a conference in Scotland. So I'm excited about those trips.
Wow. Yeah.
Um, so the one in England and Wales is just a fun personal trip. So
Hmm.
the one in Scotland, I'm going to a materials conference. Um, I just got back from Australia in December,
Wow.
where it was a green conference, um, and I learned a lot there. So, um, and then the other thing that I do personally is I go to a lot of concerts, but there are a lot of older bands, so I'm not sure if your viewers will know who they are. um, and then, uh, I'm just excited about my research in general.
Hmm.
And I'm working with undergraduates in the lab. I'm always excited to work with students and stuff like that. Um, and so that's mostly what I'm excited about.
Oh, that's awesome. So you mentioned music. How about any other hobbies that you enjoy in your spare time when you're not doing research or not teaching or in that little spare time I'm sure that you might have. Um, what are some other hobbies that you enjoy?
I put together like one or two puzzles a week.
Mm.
Um,
Mm-hmm.
and and then I also have a dog. He's a schnoodle. He's a schnauzer poodle, and he's kind of spoiled. He has two toy boxes, so he gets a bark box every month. Um, and then my mom lives 2 hours away, and I have four two nieces and two nephews, so I go visit them a
Nice.
lot. Um, so uh, besides going to concerts and stuff, I do a lot with my family, and when I'm not doing that, I hang out with my dog and do puzzles and stuff like that. And I like sports too. I think a week ago I saw the K State women play, and then
Mm-hmm.
in about a week I'm going to see them play Kansas, which
Nice.
Kansas is our rival, so I'm hoping we win.
That's really fun. Yeah, that's really cool. Yeah, so I want to kind of go back to chemistry and you're starting out your career. What kind of originally made you like what made you specifically choose chemistry? I'm kind of interested in, chemistry versus physics versus biology. Like what made you decide on chemistry and then, you stuck with that all the way through your schooling. Like what made you really decide chemistry was the one for you?
Yeah, so when I took chemistry, I realized that everything is made up of molecules.
Hmm.
And so, like, it's really a foundation of, thermodynamics. It's really a foundation of who we are and how the world works.
Yeah.
And so you can explain a lot of things through chemistry. And I'm sure a physicist would say the same thing about physics, that you can explain a
Hmm.
lot.
Hmm.
But for me, things don't click as much with physics. There's a lot of math in physics.
Yeah.
And I'm decent at math, but I don't think I'm like physics math decent.
Yeah. Yeah, makes sense.
um, And then when I went to college, to be honest, the classes were really tough.
Yeah.
And I enjoyed the labs,
Mm-hmm.
but I didn't really enjoy the lectures as much. Um,
Yeah.
and I didn't really enjoy chemistry again until I was a graduate student back in the lab doing research again. Is when I
Mm-hmm.
really enjoyed it again. Um, and I think I stuck with it because, you know, I like the subject matter. It's just, and I like parts of chemistry, but it was just some parts I was like I'm not an organic chemist, and
Mm-hmm.
all the organic chemists forgive me, but I really hated that class.
Yeah, and and I think that class, organic chemistry, is kind of commonly agreed upon as the hardest, most rigorous, worst class like ever,
Yeah,
across the board.
you either people who like organic chemistry hate PChem, but I love PChem,
Mm-hmm.
which is physical chemistry, but
Mm-hmm.
I really hated organic. But a lot of people hated organic.
Yeah.
So, what did you major in college?
I'm in entomology right now in
Oh,
undergrad.
okay. Yeah, yeah.
Yeah, yeah, but I've taken general chemistry. I don't have to take organic chemistry, so I won't. But
Don't do
but yeah,
it.
I totally see what you're saying because I've experienced this with chemistry, biology, and entomology, where well, I enjoy all of entomology, but with biology and chemistry, I really enjoyed and excelled in the labs, but not as much with the lectures. Um, and I think it's depends on the person because some people um, are really good at applying it versus really good at testing it. You know what I mean?
Yeah,
And I'm one of those applying people. So I've always been better at labs than I've been at testing or exams or anything like that. So I'm very much like yourself in that respect, um, with my chemistry as well.
yeah. I'm good at applying it and coming up with ideals, but if you saw on paper the testing part, I'm probably average, or
Mm-hmm.
I'm not. I don't think anyone would be like you're a superstar when it comes to like sitting through a lecture.
Mm-hmm.
But
Yeah.
in a lab, I excel and do well. But other people are really good at sitting through lecture and they can just ace everything.
Yeah, it's pretty interesting, the ways in which different people learn in different ways. So yeah, it's pretty cool. And like you said a minute ago, um, that's what being in science really means is getting good, getting good at always learning something, right? Um,
Yeah.
and applying it.
And I think one thing is you have to learn how you learn. And like for me,
Hmm.
the beginning of college, figuring that out took some time.
Hmm.
So,
Absolutely. Um, yeah, that's really interesting. And I found it really interesting how you went from chemistry to applying that to bugs. I thought that was really cool because honestly, a lot of the times when I have people on, it's kind of the opposite, where they have a background in entomology and then they apply it to something more specific, whereas you started with chemistry and are now applying it to bugs. I think that's really cool. And I just want to say to you listeners out there that um, you can start with bugs and then apply it to something later, or you can start with something more broad, or you can start with something more broad like chemistry and apply it to bugs later on. So I think it's pretty cool to see the different paths that everyone goes on.
yeah, I think it's really cool because when I was in grad school, I didn't realize what a big world agriculture was, entomology was.
Hmm.
You know, I didn't know the field of entomology, and now I'm like, whoa, this is like a huge field.
Oh yeah, it's huge, and you could work on, I mean, you could work on a different thing all the time, and you would never in a million years run out of things to work on or things to learn. I mean, you could make a whole career just on nanotechnology in insects. I mean, it's really exciting and really cool, I think.
Because our number one competitor for food is insects.
Yeah, and I think on the other side of things, they, we rely on them in a lot of ways for our food. The vast majority of the food that we consume is pollinated by insects, um, pollinated or eaten, or all of these things are affected by insects. So it's really important and interesting to think about how they affect us humans, and we don't even think about it. So yeah, it's crazy.
Yeah, it's really interesting. I mean, another project I'm working on is making nanoparticles out of honeys, different types of honeys, and seeing
Oh, interesting.
their effects. And that's a product that's made from an insect, and so and then there's this big push of insects for food, which will open up
Hmm.
a bunch of stuff.
Mm. So with that honey thing, tell me a little bit about that. Making a nanoparticle out of honey. What does that even look like? I'm unfamiliar.
Yeah, we're using honey as a reducting agent for silver, and
Mm.
then each of the honey has different floral sources,
Yeah.
and so we're seeing how the nanoparticles change as we change the different variety of honey.
Mm.
So there's one in Australia that's known for wound care. I forget what it's called, but it's because it has so many properties of this floral source that it comes from. It's really good for wound care. And then they also
That's
put
cool.
silver in wound care too. And so there's a lot of benefits to doing that.
Hmm. Oh, that's cool. Man, you are working on all kinds of cool stuff. It's really exciting.
Yeah, I just enjoy working and learning about stuff, and I'm really doing what I want to do in life is learning and trying new things in the lab. And
That's really cool. Well, Amy, thank you so much for sitting down with me and chatting about this really cool research, because this is super unique, and I just wanted to highlight like where people can take their interests in science, maybe apply it to entomology. Um, so yeah, I always love to highlight different careers that you can take, and paths that you can take. I mean, you can get a degree in chemistry anywhere, whereas you can't get a degree in entomology anywhere. So it really opens up your opportunities in a really cool way. So thanks so much for taking the time to chat with me about nanotechnology and the research you've been doing. It's really, really cool. So thanks again.
yeah, thank you for having me on, and I really appreciate it, and it's been a great conversation.
Awesome. Thank you so much. Yeah, I will see you guys. I will see you all next time, but Amy, thanks again. This was really cool.